time dilation. The time dilation is here today we're going to learn about time dilation. Time dilation means that when an object is moving, its time is actually slowing down. For example, when you are walking, you actually have a slower time elapsed than something which is standing still, like a chair. So, however, why don't we notice it? Because the effect is way too small. Actually, this effect was discovered by Einstein, and nobody discovered it before him because this effect is only appreciable at relativistic speeds. And if you don't know what relativistic speeds are, they are speeds which are a comparable fraction of the speed of light, basically hundreds of millions of miles an hour. Let's assume that we have a super rocket car, and let's say that we have a very specialized driver riding this car. Now this is a super rocket car, assuming that it can travel at speeds nearly the speed of light. So the driver drives this super rocket car at a speed of 0.87 c. Here, there is a formula for time dilation, but this one also applies for length contraction, which is similar to time dilation. It's just that the length is getting smaller. It's just that the length is getting smaller instead of time slowing down. But by how much does time slow down? That is according to the speed and this equation. The equation is F, the Lorentz transform, which is actually the factor for both these things, and the equation is F, the time dilation or length contraction. Basically, we'll call it the Lorentz factor, and we take this thing F. Actually, we take 1 minus the velocity in terms of the speed of light squared, and subtract this from here, and then we take the whole thing square rooted. So at our speed here, let's say that the speed is 0.87. So here, this is not totally accurate. However, the velocity squared, 0.87 squared will be 0.75. So I have 1 minus 0.75, which then equals to the square root of 0.25, which is equal to 0.5, which in turn means that this car, when traveling at 0.87 c, where c is the speed of light, has time slowing down by has half the time speed for the rest of the world. Let's say that this car moves for 6 seconds to the outside world. So, for the driver who is driving the car and the driver will actually experience a time of driving for only 3 seconds, as 6 times a half is 3. Also, if you are young, remember multiplying by half is equal to dividing by 2. This thing also applies for length contraction. And I'll show you one more example of this time dilation. Let's say that we have a super rocket ship. Let's say that it's the new millennium, and let's say it's the year 3000, and the holo ad decides to celebrate the new millennium with a deluxe rocket ship from Earth to Jupiter. So, let's say that our rocket is going to Jupiter at a speed of 0 at 2/3 of the speed of light. This is quite a fast speed, but yet the trip from Earth to Jupiter takes about 2 hours relative to the Earth, as this diagram I'm drawing here. However, according to the astronauts on board our rocket, they travel to Jupiter within only 1.5 hours, which means that the Lorentz factor has changed by about 3/4. You can see if you can calculate this with the equation, but I'm doing it myself. So, the first thing is we input the value. So the value is 2/3 the speed of light, and squaring that gives us 0.4, repeating the speed of light. So we have the square root. So we have the square root of 1 minus 0.4 repeating. Then the next step is to subtract. So if we subtract 0.4 repeating from 1, we get 0.5 repeating. Let's take the square root of this, and it will give, and if we take the calculator, so I'm doing this one in the calculator because this one's a little tough for me. So as you will see, 0.5 repeating square root will give us a square root of 0.745 approximately, which is very close to 7.5. I mean 0.75.